Hi, I'm Martin Sweatman, and in this video I'm going to continue my review of the Younger Dryas impact debate research. And so far we have covered the published research from the original Firestone paper in 2007 through to the middle of 2013 in the last video. And in this video I'm going to review the other papers in 2013. So remember where we got to last time. Nanodiamonds in the Younger Dryas black mat at several locations and in the Greenland ice sheet have been confirmed by 3 other independent research groups, and an abundance of iridium-rich rhomboidal magnetic grains have been confirmed at the Murray Springs site. Although Dalton et al. Couldn't confirm the nanodiamond abundance in their work, it's not clear they actually sampled any carbon spherules or amorphous carbon melts in which the nanodiamonds are reported to occur from any black mat sites. In fact, let me just show you the detail of that so that we can clear up this issue of why Dalton et al. Couldn't find the nanodiamonds. Let's just find their paper. So here is the 2010 paper by Dalton et al. Where they looked at 3 different black mat sites for evidence of nanodiamonds. Let's go down to the section at the bottom where they describe where they obtained their samples from. Now, from Murray Springs, they obtained microcharcoal aggregates. Now, we know that the nanodiamonds don't occur within charcoal, so straight away, that's not the correct sample for looking for nanodiamonds. Now, what about Santa Cruz? That's down here. On the neighbouring Santa Cruz Island, carbon spherules, they report, are obtained from a layer dated, well, this is many thousands of years too old. So we can rule out the Santa Cruz samples, even though they're carbon spherules, as being of any use. They don't date to the Younger Dryas period or the Younger Dryas impact. So this only leaves Arlington Canyon. So did they sample the Younger Dryas boundary there? Well, we can't know for sure. They say that they selected 2 samples of carbon spherules from Arlington Canyon, but they obtained these seemingly at random from the lowest meter of that sediment. And there's no way to know if these samples correspond to the Younger Dryas boundary. I mean, these dates loosely correspond, or at least this one does, to the Younger Dryas boundary, but unless we can see where it's taken from relative to a black mat layer, there's no way of knowing whether that corresponds to the Younger Dryas boundary. So they could easily have missed the Younger Dryas boundary at Arlington Canyon as well. So that appears to be the case. At Murray Springs, they looked at microcharcoal aggregates. At Santa Cruz, their samples were thousands of years too old. And at Arlington Canyon, there is one potential sample that might be within the right range of a carbon spherule, but we can't know because we don't really see its proximity to any black mat at that location. So quite probably they weren't sampling carbon spherules from the Younger Dryas boundary, and that explains why they didn't find the nanodiamonds. Okay, so now returning to 2013, remember there was a very strong spike in platinum in the Greenland ice, which had just been discovered, which perfectly coincides with the onset of the Younger Dryas cooling. But to have done this, the impact must have been huge. Supposing that this platinum spike and therefore an impact is the cause of the cooling, the impact would have to be huge. Therefore, by itself, the Greenland platinum spike almost proves the Younger Dryas impact hypothesis. Now, the other papers that we're going to look at next from 2013 won't know about this platinum discovery. They will have been prepared and submitted before this discovery was made public. So it'll be interesting reviewing these papers with this additional knowledge which the authors of the papers didn't have. Now, the first paper we need to look at is another paper from the Comet Research Group, which claims to find peaks in impact spherules at the base of the Younger Dryas black mat across 4 continents, amounting to around 10 million tons of spherules. Now that's a huge amount of spherules, and a huge amount of work has gone into this paper. The details are very extensive in the supporting information, and we can see a list of the various black mat sites that they analysed here. And the geochemical analysis of the spherules in this paper is very comprehensive. Okay, it's a very large work, and it convincingly shows these spherules were generated by a cosmic impact, I think. But it's complex science, and in this situation, precision of language is important. And I'm not sure that either side is being sufficiently precise with their language. For example, the Comet Research Group in this paper claim that 9 other independent studies have confirmed peaks in impact-generated spherules at the Younger Dryas boundary, but that's not true. Only Lecomte et al. From last year, 2012, have confirmed an abundance of spherules that the Comet Research Group found. Pigatti et al. From 2012 did also confirm a peak in spherules at the base of the Murray Springs black mat, but they only counted about 1/10 the number that the Comet Research Group counted, which shows that there are still problems in the methodology of counting spherules. And the other studies that the Comet Research Group cite, which they say are independent researchers, are not actually independent. They include many members of the Comet Research Group, or they don't actually show a peak in impact generated spherules. They imply this in the text, but they don't actually demonstrate an abundance peak with clear data. So in fact, the only paper that has confirmed a peak in impact generated spherules is the paper by Lecomte et al. From last year, 2012. Nevertheless, the fact that there is now confirmation by Lecomte et al. From 2012 of all of this spheral work, and with this latest work, it suggests that we should consider the spheral evidence carefully. And importantly, Lecomte et al. From last year could explain the problems with the work by Soroval in 2009, which didn't find these spherules. So the spheral evidence is now reproduced by an independent research group, Lecomte et al. It appears this evidence is quite strong, but I still have my doubts because it's not clear to me how a spherule is positively identified. So these are the spherules that we're talking about, and as you can see, there's a wide range of shapes and forms. If we go to Lecomte et al., these are the spherules that they're talking about. They are more spherical, I would suggest, than the others. So how do you define exactly what counts as a spherule, and how large does it need to be, and so on? It's all very difficult. Added to this kind of work is extremely laborious, and the analytical work is quite advanced. So although ultimately it's an interesting scientific story, I think other lines of evidence, like the platinum evidence, are going to have more weight in this debate. I think the spheral evidence is always going to be controversial, I think. In fact, let's see what their opponents say about this spheral evidence, which has been now confirmed by independent groups. Actually, first of all, we have to consider the response, or a response, to Lecomte's paper from 2012. So this is a response by Boslough. Here we go. So this is a response by Mark Boslough to Lecomte et al.'s paper in 2012, which confirmed the Comet Research Group's findings about spherules and that they are generated by a cosmic impact. Now, Boslough takes quite an unusual and frankly unsavoury approach in his criticism in his response here. Rather than tackling any scientific issues, he appears intent in his response here on questioning the integrity of the scientists involved. So that's Lecomte et al. Essentially, his main line of criticism here is that everyone is making it all up and that nobody can be trusted. Now let's be clear about this. He's accusing two completely independent research groups of lying about their results. It's really quite unbelievable. But what is his evidence for this? Okay, well he talks about it here, he states that an independently radiocarbon dated spherule obtained from Dr. West of the Comet Research Group has a date of only a few hundred years, making it inconsistent with the Younger Dryas event. Well, clearly something has gone wrong here, because this single result is not sufficient to discredit the good name of dozens of other researchers who are independently working from each other. It's really quite a distasteful attack by Boslough, and it's easily dealt with by Lecomte in their counter-response. Now, not content with this, Boslough is joined by a few other astronomers, notably David Morrison of NASA, in his response to the 10 million tons of spherules paper. So we're now back to 2013, and this is the response to the 10 million tons paper. Okay, this is now the response to this paper by Boslough and a few astronomers. Okay, so here it is. We've got Mark Boslough, Alan Harris, Clark Chapman, and David Morrison of NASA. Now, David Morrison is an important figure in this debate because he led the 1992 SpaceGuard inquiry into the impact threat to Earth from asteroids. Now, at the time, this was an important inquiry, and David Morrison, who chaired it, were very influential in setting up a global SpaceGuard strategy for observing near-Earth asteroids, one that is still ongoing and has been very successful. But note, this inquiry didn't address the threat to Earth from large fragmenting comets. And of course, the Comet Research Group's favoured scenario is specifically aimed at a fragmented comet. So immediately we can expect Morrison to be quite unfavourably disposed towards this evidence of a relatively recent comet impact, something his 1992 NASA SpaceGuard committee practically ruled out. So what do they say? They've got two key objections, and we're talking science now. These are no longer character assassinations. First, they say the fragmented comet scenario is extremely unlikely. But no, they're only considering a single fragmentation event of a small comet. Then they say that even if the impact was with fragments of a comet, if the fragments were the same size as, say, the Tunguska impactor from 1908, then no microspherules would be created, since the Tunguska impact didn't create any. Now, Bill Napier, who developed the theory of coherent catastrophism with Victor Klube, on which this fragmented comet impact scenario is based, joins the Comet Research Group to respond to these criticisms. So this is now a counter-response paper. Here we go. Reply to Boslough. Decades of comet research counter their claims. Now, at this point, you should know that David Morrison is a long time and particularly harsh, and I mean really harsh, critic of their theory of coherent catastrophism. So I'm talking about Bill Napier and Victor Klube, their theory of coherent catastrophism. So he's a particularly long time and harsh critic, which is why the NASA SpaceGuard Committee completely ignored it in their 1992 inquiry. So these gentlemen, Napier and David Morrison, have a history. Now, Napier's response is that Boslough and Morrison are, once again, completely ignoring their work from the last few decades, which Morrison knows very well. He knows the work extremely well. He's criticised it extensively. Now, Napier points out that a large comet, say 100 kilometres across, would produce thousands of fragmentation events, not just one, making several collisions over the last few tens of thousands of years on the scale suggested by the Comet Research Group, quite likely. So it all depends whether a comet of this size, about 100 kilometres or so in diameter, has actually been orbiting within the inner solar system on this timescale. Now, of course, the conventional view of astronomers like David Morrison is that there hasn't been, but Napier's group of cometary scientists can point to their own research over the last few decades, which shows almost certainly that there has been. And I am firmly in Napier's camp. To my mind, the evidence from their work is very clear and very strong in their favour. In fact, now is a good time to go back to Napier's 2010 paper, which is in our bibliography, which I deliberately left until now to discuss. So let's just find it. So in this paper, Bill Napier describes his theory of coherent catastrophism, which can account for the Younger Dryas impact. Now again, the first thing he shows in this paper is that if a giant comet has been trapped within the inner solar system over the last few tens of thousands of years, then an event like the Younger Dryas impact is quite likely. It's expected. There's really no argument here, it's just a matter of probability. So it all depends on whether a giant comet, about 100 kilometers or so in diameter, has actually been orbiting within the inner solar system on this timescale. So what's the evidence for this? Well, there are two key lines of evidence which are very compelling when put together. First, there is the large mass of the zodiacal dust cloud. So this is the dust generated by comets as they decay in the inner solar system. And essentially right now, there is rather a lot of the stuff. There's a lot of dust, zodiacal dust, in the inner solar system, indicating a lot of cometary activity over the last few tens of thousands of years, much more than we currently observe today. So the most likely explanation for this observation of lots of leftover zodiacal dust is a trapped giant comet. Second, if we analyze the statistics of known objects in near-Earth space. Now specifically, if we look at the orbital characteristics of the 20 largest known objects in orbits similar to Comet Encke, we find they are bunched around Comet Encke in terms of their longitude of perihelion. So this is Comet Encke here. This is the longitude of perihelion of the 20 largest objects in orbits similar to Comet Encke, but not constrained in terms of the longitude of perihelion. Then we see that they have this sort of strong correlation with Comet Encke here. So essentially what this means is that almost certainly most of these large objects, including Comet Encke, which are all over a kilometer in diameter, are comet fragments generated by the disintegration of a very large progenitor comet. And other work, which I won't discuss in detail here, suggests these fragments would have taken somewhere between 10 and 100,000 years to disperse like this if they were generated by the disintegration of a giant comet. So that's consistent too, the timescale is consistent. Now, as far as I know, there is no other way of explaining this correlation in the longitude of perihelion of these large objects that have similar orbits to Comet Encke. Now conventionally these objects are thought to be asteroids and have nothing at all to do with any comet, but this evidence shows almost certainly, and because of the large mass of the zodiacal dust cloud, these are actually dormant comet fragments. And note that at this time it's practically impossible to distinguish between a true asteroid made of mostly rock and metal and a dormant comet fragment, simply from telescopic observations. So put this all together and the evidence suggests that almost certainly the trapped giant comet scenario is correct. It's a statistical argument based on the existence of these large fragments in orbits similar to Comet Encke and the existence of the massive zodiacal dust cloud. So almost certainly the giant comet scenario is correct, and therefore almost certainly the Younger Dryas event or impacts like the Younger Dryas impact event are expected. In fact, we should see many events like this, maybe none quite as large as the Younger Dryas event, but we should see many events like this over the last few tens of thousands of years. So with this in mind, we can actually now go back to the work by Pagatti in 2012, if you remember, where they looked at a range of different black matte sites, all on top of each other from North and South America. And remember, they found evidence of spherules, magnetic spherules, and iridium abundances at lots of these black matte sites dated up to 40,000 years or so. So again, this evidence is completely consistent with the the possibility of a giant comet fragmenting within the inner solar system that we've been colliding with every few thousand years. So collectively, this stream of comet debris orbiting in near-Earth space is known as the Taurid meteor stream. Now currently this meteor stream is very weak, but because of the way its orbit changes, we can expect the Taurid meteor stream to become much more interesting in about 1,000 years' time. And remember, I suggested that the 8.2 kiloyear event, Black Mat in particular, probably corresponds to one of these cosmic collisions. So let's now, having explained all that, let's go back to the response that Napier and the Comet Research Group made to David Morrison and Boslough. So Napier points out the fact that there probably was this large comet, this 100-kilometer comet, breaking up in the inner solar system, and therefore, because of the large number of fragmentation events, it means that a collision with one of these broken up comets would have been quite likely. So that counters Boslough and Morrison's claims. On top of all this, Napier and the Comet Research Group point out that Boslough and Morrison et al., they've got no alternative explanation for why around 10 million tons of what appear to be impact-generated spherules across 4 continents, and not to mention all the other geochemical evidence, can have been generated. So as Boslough and Morrison et al. Provide no alternative scenario, theirs is not really a satisfactory scientific position. Indeed, we can even take this geochemical evidence as vindication for the work of Napier and his buddies over the last few decades. It's essentially a slap in the face for the conventional astronomical view, and it's another reason why this work is so controversial, because it's not just many Earth scientists and archaeologists who are set to lose out in this debate, it's the bulk of the astronomical community too. So this debate rewrites the rules for the kinds of impact scenario we have to consider. According to Napier and his crew, it's large comets from the outer solar system that are a much greater threat to us than all of the asteroids in the inner solar system put together. And right now, the remains of one of these large comets are orbiting within the Taurid meteor stream. And of course, people like David Morrison hate this idea, because it means the NASA Space Guard Committee he chaired in 1992 was barking up the wrong tree by focusing on asteroids and by not considering the specific dangers of the Taurid meteor stream or the disintegration of other large comets. So you can see there's a lot at stake here. Now finally, Boslough and Morrison's view that a collision with Tunguska-sized fragments wouldn't produce any melt spherules is also nonsense, which is dealt with in this response, because it doesn't consider comet fragments which are slightly larger than Tunguska, which would, so their criticism is easily dealt with. Now we can consider other criticisms of the 10 million tons of impact spherules paper. So first of all, there is a response by Van Hoesel et al. So remember her work from an earlier video where they dated the Younger Dryas Black Mat at a location in the Netherlands by radiocarbon dating a piece of charcoal from 5 centimeters above it. So again, the Comet Research Group can easily counter her claims, which as we have seen are ridiculous. So then there are complaints by Ives and Froese. Let's just find Ives and Froese. They question the use of the Chobot site. So this is one of the many sites in the 10 million tons of spherules paper that was analysed. They question whether the Chobot site can be reliably dated to 12,800 years ago. And actually they have a good point, I think. The only evidence provided by the Comet Research Group that the specific Chobot site, Black Mat, dates to the Younger Dryas period is the presence of a few Clovis spear points immediately below the boundary layer. So the Black Mat at Chobot is only dated by this inference, by the presence of some apparent Clovis spear points. So I think I agree that this site shouldn't have been included by the Comet Research Group, and essentially the complaint of Ives and Froese is upheld, I think. So in the end, criticism of this spheral work is easily countered apart from the dating of the Chobot site. And I think we can add the site in Mexico examined by Israel Alcantara to this list of problematic sites as well. Remember, there are real problems with the age depth model in that work. So in fact, this issue of reliably dating black matte sites is an issue we'll return to when we look at papers in 2014. That's like the big bugbear of 2014. So we'll leave a fuller account of this issue until another video. But overall, it seems like this spheral evidence is generally good and should be considered strong evidence in favour of the impact theory. Okay, so now moving on. Finally, we've got two papers that investigate whether specific chemical elements can be used to confirm or refute whether a cosmic impact occurred precisely at the onset of the Younger Dryas period. Remember, these groups were unaware of the platinum evidence, so they were looking for other chemical indicators of an impact. So we have this paper by Wu et al., where they look at osmium ratios. That's one of these papers. And we have another paper by Overholt and Mellot, where they look at essentially aluminium and beryllium isotopes. But in the end, I'm not going to go into the detail of these papers, because in the end both of these groups show that these lines of evidence are inconclusive in identifying the nature of the Younger Dryas event. In other words, these particular elements are not diagnostic for the impact event. So we'll quickly move on from this work. So 2013 was a pivotal year for the impact theory, with the discovery of the platinum signal in the Greenland ice sheet. The spheral evidence, the 10 million tons of spheral paper, along with the nanodiamonds and weak iridium signal, shows the impact was probably a single event, widely distributed across several continents, indicating a fragmented comet. Now, I can't see any reasonable alternative explanation for all this geochemical evidence. And importantly, the platinum signal in the Greenland ice shows very likely it was the impact that caused the Younger Dryas cooling. So whichever way you look at it, if megafaunal extinctions and human population bottlenecks are confirmed to occur at the Younger Dryas boundary, as Vance Haynes tells us, then we can blame this cosmic impact as the fundamental cause, as the Comet Research Group have been saying. If the platinum signal is confirmed at other Younger Dryas black matte sites, then essentially their work is done, and probably also so is Bill Napier and Victor Kloob's. Okay, so if you like that, then stay tuned for the next video, which hopefully will be a little bit less complex, which will follow in a couple of weeks, and take a look at my blog, martinsweatman.blogspot.com, and take a look at my book, Prehistory Decoded. So in the next video, I'll look at the papers published in 2014, which by and large focus on the quality of the dating of the various Younger Dryas black matte sites.